Okay. Now, what we're doing here is we're going to do two different types of problems. The first one I'm going to show you today, I'm going to leave you, there's not a lot of them on the practice problem sheet, okay? So, what you're going to have to do is make sure you write down everything I do, but we are recording this, so I'll put it on the website. The first problem is this one on page 138 of the problem set. And what I'm going to show you how to do is, this is going to be your final equation that you're working toward, okay? That's what you want to get out of these two equations right here, okay? So, the first, the original one that, or the final one that we're trying to get, and remember that you've got to make sure that you put in your states, because they're important to you in this. Because I'm going to tell you, you're going to be canceling some things out, and you can't cancel anything out unless the states are identical. Okay, so this is what we're searching toward. This is what we want to get. And we have to get to that, and then we have to calculate the change in enthalpy. Okay? And I'll show you that in just a second. So these are the two equations we're using. We're using CO, and all it is, y'all, this is rearranging things and making sure you do it in specific ways. This is plus 520.9 kilojoules. Now, this is the change in enthalpy, okay, for that reaction only, okay? And then the second one we're going to use is and the change in enthalpy for this one is positive 461.05 kilojoules. Yes, Francis?
Does it always give you, like, it's a given kilojoules? You don't have to, like, figure
Yes,
out how many?
yes. What we're going to figure out is what the overall change for this top one is,
Okay.
using these two.
I was just asking so
Yes.
I know where they came
Yes, they will. Yes, they will. Yes, hon. Sometimes you'll have to change from joules to kilojoules.
But not this one.
No. Because it's already given to you in kilojoules, right? Okay.
And you have to find stuff.
Okay, now can you let me explain before you ask a bunch of questions?
Yes, ma'am.
Thank you. Okay, now, the point is we want to use these two equations to get this. That means something's got to cancel out, okay? And we already know that the first thing I look at is that one. I need 5 CO2 on the left-hand side. And I have 8 here, okay? That means I've got to have enough CO2s right here to cancel out all but 5 of these, okay? You get me? So I'm going to multiply this entire equation times 3. Now, I'm going to bring it down here because I like to keep them separated. I'm going to say 3CO okay. And what you need to remember is that because I multiplied that entire thing times 3, I also have to multiply that times 3, okay? So now, instead of this being what I have, now I have 1562.7 kilojoules for this one, okay? Now this is what I'm going to do. I'm going to cover this top part up, okay? And I want to look to see, well, I don't want to do that. I just don't want to look at this one anymore, okay? I know that I have to have 5 CO2s, right? I can cancel all but 5 of these out and get rid of those, okay?
Why would you?
How do you get rid of those? How can you cancel?
Because they have to be on opposite sides of the arrow, okay? Anything that's on this side that's like the ones on this side, I can cancel. I'm trying to get this same equation out of these two, okay? So I need 5 CO2s. I had 8. I multiplied this one times 3 to be able to cancel out 5 of those CO2s. Okay? Now, this has got to be here. Do we have it anywhere else on the other side? No, that's fine. How about this one? We need, okay, yeah, there's 3 of those and 3 of those, so that's gone.
Wait a minute, can you cancel them out if they're in different states?
But you need to do it.
No, let's see, wait a minute, I think I wrote something down wrong. Hold on. That's supposed to be a solid, okay. So, no, they're not, you're good question. That's a solid. So I'm canceling those out, okay? I also, I know I have 2 N2O, so that's good. I have 3 SiO, that's good. But I have 3 COs here, and I have 8 here, and I need 5. So all but 5 of those are canceling. So this is what I have left. I have left, where's my 5 CO2s, and this is Si3N4 solid. And then I'm going to this one.
Oh, so you're just combining all these together?
Yes. And you have to cancel out things, you know, so that you get rid of all the others. And we'll understand this part over here in just a second. And so then we need 2 N2O gas plus 5 CO. Okay, now,
You just add those together.
that's what we did, yes.
No
But
changes.
just a minute. If you can just wait just a moment, I will explain it, and then you can ask me questions, okay? Now, I multiplied this one times 3, so I multiplied that times, this right here times 3 to get that, right? Okay, so I'm going to say 1562.7 kilojoules plus 461.05 kilojoules, and I end up with 2023.75 kilojoules. That's my answer. This is the change in enthalpy for this reaction here. And that was what your goal was, to figure that out. Now, let me explain something else. We're going to do another one in a second. If, say, now let's just do another one. I'll, how many, what were the numbers in the problem?
They're rounded.
They had 4 sig figs was the least, so you should round. 2024 would be your answer because of sig figs.
Instead of doing all that, couldn't you just multiply those numbers by 3 or something? Like
You have to show this to make sure you've done it right. Okay? And you'll understand in just a second when I do another one. Okay?
Okay.
Okay. Now, turn the page and go over to number 2 on the back on page 143. Page 143, the back. It says additional problem. Now, this is a fairly long one, okay? Mm-hmm. Okay. Okay, so this is what we're looking for. And the point is it takes 4 reactions to get that. It's not so simple as it looks, okay? So we're using these reactions. Now, one of the first things I see is that, number one, there is no water in the first equation, and there is no just plain calcium. Okay? Also, I see that these waters could cancel, but these two calciums can't. Why can't they cancel? Because they're both on the same side of the reaction. One has to be on the other side, okay? Now, we also need sulfuric acid to cancel out, right? And we want CaO on the left side, so we're going to flip this one, okay? And when you flip this, this is what you get. Oops. And I have a positive 634.9, okay? Because when you flip, you change this. It's just like physics. You change the symbol, okay? So now let's look and see what all we can cancel. We know we can cancel our waters, right? We can now cancel our sulfuric acids. We can now cancel our calciums. There is no oxygen, but we can now cancel these. And there is no hydrogen, so now we can cancel those. So we now have CaO solid plus SO3 gas yields CaSO4 solid. Now, this is what we got to do. Negative 132.5 plus negative 602.5 plus 634.9 plus negative 285.8. And the sum of those now will give you your answer, okay? Oh,
So it doesn't matter if the equations are balanced?
They were balanced.
No, they weren't.
Well, we'll find out in just a second.
Do we want to read the boundary? Yeah. The charges cross. Ca is C negative.
And this is your answer.
How is it H4? It's H2. You combine the two. It's H2 plus O2. So it'd be H2O.